This is a preliminary ozone test for aviation clean air. We have 6 aviation clean air components lined up here in very close proximity to all the test equipment. That's to show the worst possible case scenario for producing ozone. So, what I'm going to do is I'm going to define all the equipment. 6 ACA RN 0001 aviation components. This is an ozone monitor that measures in parts per billion with the most sensitive sensor available. This is an air ion counter that measures the amount of positive and negative ions we're producing. This is an ozone sensor that measures in parts per million. We also have a circulating fan over here. Puts out 669.6 CFMs of circulating air. We have a second household fan here that puts out 762.5 CFMs. And we have supply air coming out of the duct system that supplies the air to this lab. It measures 408.4 CFMs of entering airflow. We've also utilized this airflow meter in order to take the readings for both fans and the entering air. This ozone monitor, I'm going to mention again, that measures in parts per billion with the most sensitive sensor available. Right now, none of the components are on. And what we're measuring now are just naturally occurring ozone that's in the air. Right now it's at 13.0 parts per billion. In observing this monitor for the last couple of days, it will fluctuate anywhere from 2 parts per billion all the way up to 22 parts per billion of naturally occurring ozone. This is the air ion counter, and right now it is measuring positive on the positive side, and we have somewhere around 300 positive ions per cubic centimeter. This is times 1,000, so it's at 0.3, so that makes it 300. It also measures the negative side. And it will drop down to somewhere approximately the same range, I would guess. But right now it's measuring 600 ions per cubic centimeter. That's negative ions. This is the air intake for this most sensitive ozone monitor. The air for this air ion counter goes directly in here and goes out the bottom. It's processed through the piece of equipment. Right now we have 40% relative humidity, 77 degrees Fahrenheit, and 964 millibars of pressure in the lab. What I'm going to do is I'm going to turn on these 4 components to begin with. You will see this value go to a held -1 almost immediately. But we're at 13.1 parts per billion on the ozone monitor. So I'm going to turn these 4 on at one time. We're now at a held -1, which means we're making more than 20,000 ions, negative ions per cubic centimeter. The ozone monitor was at 14. Now it's at 16.5, but it will go back down 15.1. This actually measures and reports every 5 seconds, so now it's at 13.7. $11.6. So we're actually lower than where we started when we turned these 4 on. 13.0. So there's really no appreciable increase at all, any significant increase, with 4 of the ACA units operating. What I'm going to do now is I'm going to turn on the 5th one, which is this one right here by this power source. You can tell they're on because they all have LED indicator lamps on, and you can tell these 4 are on by those 2 indicator lights. We're still at -1, which is 20,000 negative ions per cubic centimeter. We had 11.9 parts per billion with 5 of the units on. So we're still below where we started. 14.8, we're just on the other side of where we started. I'm going to go turn the 6th one on, which is this one, which has a different power source. Green indicator light's on. We're still at -1. So held -1, which is negative 20,000 ions per cubic centimeter. We're at 16.3 parts per billion. 16.9, but it will go back down. $14.9. So we're starting back down again. Intake for the parts per billion. I'm going to change it from the negative side to the positive side to show that we're making over 20,000 ions per cubic centimeter. It's held. It's a held -1. We're at 15.2 parts per billion with 6 of them running. 15.2, 17.0. .1. 20.6. 19.9, and it'll go back down. $19.4. But this is absolutely the worst case scenario right here. We've got 6 of them in very, very close proximity to the ozone monitors. 19.0. It takes 2 of these to do a Gulfstream 650. It takes 4 of them to do a A320 size aircraft or BBJ 737. I can also take this handheld parts per million, and it's operating. And I can actually stick it right at an ionization source on each and every one of these, and it never moves. It's always 0.00. We're down to 15.0 parts per billion. $16.6. 18.4. So, with 6 of them running, 18.3. We started out, I believe, at 13.3 or something like that. So with 6 of them running in this close of a proximity, 17.2, we are maybe making, now it's down to 16.0 again. That's 3 parts, less than 3 parts per billion. 15.3, and I'm sure if I left it here long enough, it would get down below what we started at. 14.7, we're going down. But this is just a preliminary, it's not the protocol. I just wanted to do this setup just to share with everyone else. And that concludes this preliminary test.